Hello friends, welcome back to my YouTube channel Infinite Knowledge, and this video is specifically for the electronic circuitry series, and it is for the commutation technique, and which is a class B commutation, and why the commutation required, and what is the purpose of class B commutation and how it's work. We will understood all the things in this video. So let's get started without wasting any picoseconds. So I am just explaining once the basic circuit and basic principle of the SCR, and then or you can see thyristor also, and then we will implement it or we will see how class B commutation work. So this is a basic circuit in which one is battery, one is our SCR, and one is our load, and load is our lamp. So once I start this simulation, load gets off. Why load is not getting power? Because of the transistor is not a transistor. SCR is not on. Whenever gate supply, this one is for the gate supply, and whenever the gate supply is occurred, or whenever the gate supply is given to this SCR, SCR will gets on, and the load will get supplied directly from this battery. Like this way, the current will flow. Now you want to switch off the circuit. You don't have any specification, you don't have any switch to turning off the SCR, because whenever the DC supply is given to the SCR, and once the SCR gets on, you cannot turn it off. You need some commutation technique, some termination technique to switch off this SCR to turn off this load. So you can see here, whenever I gave the supply, the SCR is on and my load is getting continuously power. Now I need some extra switch to turn off. So if I am adding some extra switch, then and there I can only switch off my SCR circuit. Why? Because this is a constant supply. DC is not changing its polarity. So if I am first press this switch and this, okay, so my uh, uh, lamp is on. Now I want to switch off the lamp. I need to switch off the DC supply, and once again I need to switch on this DC supply, and then I have to, or I need to switch on this to get my uh, lamp on. So in in specifically when you are talking about the DC supply, you need some extra commutation circuitry to turn off your SCR, and that is possibly by some unique techniques like commutation techniques. There are a number of techniques for commutation. Here we are learning about the class B commutation. So here very clearly, just I am showing the simulation. Once my simulation is gets on, the supplies flow from this direction. My capacitor gets charged, and this way. Once my capacitor gets charged to same voltage as the supply voltage, my capacitor gets a similar voltage to this battery, so it will oppose the current flow, and my load gets on. So whenever I start the simulation, my load gets on for a very small time, and then it's switch off, because during this time my capacitor gets charged. Once it's charged, no current will flow through this circuitry, no current will flow through this path, and my lamp is in off condition. But whenever I switch on the SCR, the current will flow from this direction for a specific time. So okay, whenever my switch is pressed, our lamp gets on, and whenever I remove, my lamp gets off. So you don't need any extra switch, because here I have used the commutation technique. So how this commutation technique is work? So it's a very simple. Whenever I start the simulation, current flow through this direction. My capacitor gets charged. Once I switch on this, there are two current flowing through this SCR circuit. One from this way, and one another from this charger capacitor. Charger capacitor will flow the current from this way. So there are two different mode. If I am explaining in this circuitry, so it is a similar circuit to our proteus model. Okay, and you can see in the mode one. In the mode one, our current flow from this path EBC to LCRL, and my capacitor gets charged by this polarity. Once my capacitor gets charged, and whenever I switch on the transistor by any external pulse, my transistor, not a transistor, why I am using a transistor, or whenever I switch on the SCR or a thyristor by external pulse, the current flow from this path, and one another current flow from C to L to T, like this way. Two current flow, one from this path and one another from this path. You can see here in mode 2 there are two current flow, as I explained. uh, Now in the mode 3, what happened, here you can see here L and C is a combination, and it is creating LC oscillatory circuit. So what is mean by oscillatory circuit? Capacitor gets charge and discharge, inductor gets charge and discharge. So LC oscillatory circuit. You can see here in the oscillation you are getting this type of oscillation, and this is produced due to charging and discharging of capacitors and inductors and vice versa. So in the mode 2, until mode 2, I think so you understood. There are two currents flowing at now. The transistor one is from this way and one another from this way. Whenever this current flow, capacitor gets discharged and inductor gets charged. Okay. So after completing your mode 2, your capacitor is totally discharged and your inductor is totally charged. In the mode 3, again your capacitor gets charged due to this inductor, due to this magnetic field stored in the inductor, and due to in the mode 3 in the third cycle, your inductor gets discharged and your capacitor gets charged by reverse polarity. So you can see in the mode 3, your current flowing from this path CTLC, C negative TLC. So here in the mode 3, your current direction is opposite. Whenever in the previous one your both current like flowing to downward direction, but in the mode 3 your current will flow from opposite direction to your load direction. Load current direction is from this part to this part, but your uh, uh, this inductor capacitor charging path is like this way, opposite to your load current. So this, due to this opposition, your load current is gets zero, and due to that your uh, resistor gets turned off. Okay. So here again explain similar way. This is supply when the gate supply is given. Uh, your ET means your voltage across the SCR, and your current is flow. And once your current is increased, okay, here your current is decreased. Is IT means the current that is flowing through the resistor. It is decreased in mode 3. So it is nearly zero, and your load current will get zero, and your transistor get, not a transistor, thyristor gets turned off. Okay. So if I am here again, whenever my I press the switch means gate pulse is given, and after some time or after a particular time, the thyristor gets turned off by this class B commutation technique. So here, if we are use a digital oscilloscope for better understanding, whenever I press the switch, okay, it's a very crystal clear. Uh, okay, I am remove auto, and okay, for a certain amount of time, you are getting output voltage, and this is your capacitor charging discharging cycle. And once your gate pulse is completed, uh, actually this is happening three times because the time duration for switch on and off is very high. If it's because I am manually switching on and off. Due to this, it's happened actually three times. But whenever your pulse is very small time duration, you are getting only one cycle, like only one time, not a three times, only one time. Okay, and for a particular time you are getting high voltage, or a particular time you are getting load current, and after the some times or after a specific times depends on L and C combination charging and discharging cycle, your current After a specific time, your current gets zero in this resistor and it will turn off automatically. Okay, so if I am again switch on and off, you can see so very clearly for a specific time output is high and then it's a zero. For a specific time load current is low and then it's a zero. If I press it continuously, we are getting a continuous output. And if I press it intermediately, I get very small time and then it's zero. So this is how class B commutation actually work. And if I made any hardware for this specific class B commutation, I will upload video. So thanks for watching this video. If you have still any query, just comment it. I will definitely reply. Thanks for watching this video.